All right, this is chapter 4, number 27. The problem reads, there are two snowcats, which look like little Arctic vehicles of some sort, towing a housing unit to a new location somewhere in Antarctica. And you can look at the picture in your book. It says the sum of the forces FA and FB, which I've got labeled FA, FB. So the snowcats are out here, actually. Okay. The sum of those forces exerted on the unit by the horizontal cables is parallel to the line. So they want to know the total force parallel to this line. Okay, and they give you that the F of A, the force exerted by A, is 4,500 newtons. And they want us to determine F of B. Okay, so in this particular problem, we've got two vectors, and it's moving this way. Okay. Now the important part to remember that is if the object is moving this way, then I know that the forces that are acting horizontally must be equal to each other. Okay. So if I know one force and it's at an angle, then I know it has both a y and an x component. Okay, and that x component here and the x component of f of b must cancel each other. So I'm going to do a little drawing right here. Just going to say this right here is the 4,500 newtons, and it has a y and an x component. So if this is FA, then this is going to be FAY, and this is going to be FAX, and this is a 50-degree angle. So using my knowledge of trigonometry here, okay, if I want to solve for the x, that's the opposite side and the hypotenuse. So if we did the sine of 50 times 4,500, we would get FAX, and I've already done the number crunching, so that's this value. And if I want that, we get the cosine of 50 times 4,500. That would give me FAY. Okay, and I did that one, 2893. Now if I draw the other vector, it's off here. So it's also going to have a y. So this is FBY and FBX. Now we want to know what this value is. I want to know that. Now I already know that this and this must cancel each other. So I already know this is 3,447 newtons, and I'm going to need to know this value, and I have an angle of 30 degrees. Okay, so I'm able to solve for all the rest of these because I know FBY, or I'm sorry, I know FBX, so I can solve for this and solve for this. So I just have to start plugging in numbers. So if I want to solve for FBY, okay, I have the opposite and I want the adjacent. Okay, so this is going to be a tangent of 30 degrees is the opposite, which is 3,447 over FBY. Don't forget that these two really just essentially change spots when we rearrange to solve. So you get FBY being 3,447 divided by the tangent of 30 degrees. If you do that, 5,970 newtons is what you get. And then we can use Pythagorean theorem, or we can use this side to get f of b. So this is the hypotenuse and the opposite side. So if I do the sine of 30 degrees is 3,447 over FB, then I get FB being 6,894 newtons. Okay. Now, I believe in the question, though, they said determine f of b and the magnitude of FA and FB. Well, since the sum of f of A and f of B only really include the y components, since the x components cancel, then I know that the sum of all those forces in the y is going to be the 2893, that's this one, and the 5,970 newtons, which would give us a total of 8,863 newtons total acting on that particular housing unit. Okay, so that is number 27. That's a pretty good problem. Okay, all right.